Oh, we can't hear you for some reason. Oh, you're muted.
I
Jessica.
requested to share my screen. Oh, here we
Okay.
go. You gave me permission. Perfect. Yay. So, this is like it's going to be an interesting journey for all of us, but I spoke at a conference, in,
Jessica. Yep. Yep.
yeah, I spoke at a conference, Data Day, Texas. I'm not sure if anyone has heard of that conference in January. It's kind of an epic, non-vendor conference. And during that conference, I did a presentation called We Are All Librarians. And what was really cool about it, was just from discussing with the audience. I don't know if many of you know Ole, who wrote the data catalog book, and also has the concept of the metagrid, but he was in the audience and he helped coin this term for what I presented called the ontology pipeline. And I don't know how many of you are familiar with knowledge graphs or ontologies or have heard much about how useful ontologies are for helping to structure data, for example, for AI to get more reliable results, for graph RAG, for things like that. And so, Stuart, I asked him a couple of days ago, what would you be interested, in me presenting? And he mentioned a really easy or nice way to help to build ontologies for, to help structure data for AI. So I put together this presentation specifically for you guys. Um, Starting off, one of the questions is, do you organize? Do you organize your data? Do you organize things? Is this part of your work or your everyday workflow? Another thing is, do you research? You know, and when you don't know something, most of us research, we'll look it up. That's one of the benefits of AI is we can tend to use AI, for example, for research purposes or to do quick searches on things. It's not always 100% accurate. And many of us educate. I don't know if any of you educate where you help to teach other people how to do things. Pretty normal if you work in tech. But most of us, part of the learning process is also teaching. So most of us fill those shoes in some form or fashion. Or do you track provenance? So some of us in the data world, or if you work with systems, or even if you don't work with systems, you might just check to make sure that, the lineage of something is protected, like personal data. It can include your personal data. And most of us deal with information retrieval. And so that includes just simple, online searches. It could be reading a book. There are many different ways that you can retrieve information, but most of us are pretty familiar with that. If you do all of these things, essentially you are a librarian. And that's because these are the fundamental core values and the core tasks of librarianship. And we're finding librarianship and libraries come more into the purview, now because of AI, which is exciting. And so the context for that is I actually am a librarian by training. I have a master's in information and library science. And finally, the way that librarians structure data, um, originally does take a knowledge graph shape. Librarians have been structuring data for digital systems, since the 50s. And their systems, catalog systems, were the first to come online. It just so happens that with AI, these library catalog and record systems are the foundation for a lot of the training data that AI uses. So if you think of how AI is trained and how data is represented and how concepts are identified, a lot of it is actually thanks to libraries, which is another important reason we need to preserve them. So because we're all librarians, we all are having to, play the role of, all of these different roles within librarianship, mostly because I'm sure many of you are also familiar with hallucinations, some of the issues around hallucinations with AI and how to optimize for AI. So the most important thing is making sure your data is ready for AI. Um, and this includes cleaning, standardization, having some framework for structuring or organizing your data, and being a very astute observer, because it's very easy for things to go off track and for hallucinations to happen with AI. AI is notoriously LLMs will make things up. They are very, very, very creative. And so, in order to safeguard from these hallucinations or that sort of agency and creativity, it's really important that you structure and prepare your data accordingly. So this is where the ontology pipeline comes in. The ontology pipeline, I also have a Substack article that I wrote about this and published because it's a repeatable framework. It's a way to create basically a profile for your LLM. It starts with a controlled vocabulary. So that's like, can be a flat list of terms, terminology, or concepts, or whatever you want to define. It's basically creating a constraint around your system. So that means like, okay, I'm using AI, I'm going to build this app, but I don't want it to stray or go outside of this sort of domain or this sort of profile or this digital thumbprint I'm creating that defines sort of the characteristics or the profile of my data and the expected output. I don't want it to go out of bounds or I want it to stay in its lane. The next is a thesaurus, and the plural being thesauri. And thesaurus, starts to reconcile. Thesaurus actually uses an ontology, a very basic ontology, but many of us are familiar with thesauri from school, and you look for an alternative word for that. If any of you work in tech, you may, or even have websites, this may be leveraged using keywords. You might just have keywords alongside a specific term, but there's a way to encode from a thesaurus so that you can have that entity reconciliation, which is really, really important. Taxonomy. So that's a hierarchy. Most of us in elementary school, even, the most common exercise is creating your family tree. You have your grandparents, your mother, your father, your sisters, your brothers. You might have divorces and deaths and births and whatever, but essentially that's your taxonomy. And ontology is formal domain description with classes, relations, and logical axioms. And this is the one part that just blows people's minds because it comes from philosophy. It's the aboutness of things. It's description, it's logic, but it's an encoded structure. And that encoded structure tells machines the context and the meaning of things. So, very much like philosophy, although there's constraints. That's the difference. The constraints for machines. So first, we're going to get into controlled vocabulary. We're going to kind of blow through this because I'm going to teach you a really fun, hacky way to create all of this yourself. So controlled vocabulary, this is actually taken from NASA's controlled vocabulary or glossary. It's a list of preferred terms, standardized terms, and they're defined, you deduplicate them, and they're disambiguated. When I say disambiguated, it means that they're defined. They're distinguished from one another. And so a data catalog or any sort of catalog or even an index in the back of a book is an example of a controlled vocabulary. If you have ever cooked and there's like an index in the back of the book and you're looking for recipes about, I don't know, beans that involve beans, you'll see things that say see also. There'll be reference terms to help direct you. Or in this case, mission to planet Earth, you can see that use for MTPE, UF, MTPE, that's telling us that that acronym reconciles with mission to planet Earth. So you reconcile those sorts of things as well. But that's a little bit more complex. But the idea is you have a controlled vocabulary and you have one word, main word to describe that thing. Metadata standards. Now, I include this because a lot of people do have metadata standards. It's the way you might label or tag something, for example, within your own system. So, metadata standards often will have a lot of rich context and vocabulary. So, you want to make sure that your controlled vocabulary, which serves as the values for the metadata, you want to make sure that there's some alignment there. So you want that consistency between the two systems. You don't want to be using different tags than your controlled vocabulary if you think about it that way. Taxonomy. So I often put taxonomy before thesauri. That's my personal preference, but they're interchangeable. This is just a taxonomy that I built within a middleware system. And it's a hierarchical classification, or it's a way to categorize things. So in this, it's Adobe Experience Manager is level 1, administration and security level 2, access control level 3. This is a little trick that I want you guys to remember is in parentheses, you can disambiguate by assigning the term, that disambiguation setting machines love. So the AEM is the acronym for Adobe Experience Manager. That means that these terms are unique to Adobe Experience Manager. That's a little trick. Thesauri. You're going to have a thesaurus. It's going to have narrower terms, synonyms, broader terms. You're going to have a nice framework that reconciles terminology dynamically across a large ecosystem. So this encoding structure, it's going to have a list of terms. It's going to have also associative relationships, not just parent-child, but also related. And you're going to have a set of rules on how to use this thesaurus. And it seems overwhelming right now, but you'll see that this is going to be distilled into something very digestible. And finally, ontology. So ontology, basically an ontology encodes things in a structure called a triple. And the triple shapes it as subject, object, predicate, or subject, predicate, object. There are different sort of organization frameworks, but generally subject, predicate, object. And within that, you're basically declaring things as, for example, ontology is related to structure. That would be a triple statement. So related to would be the predicate, but the idea is to create these dynamic relationships and add rich descriptive context to the things from your taxonomy, your controlled vocabulary, your thesaurus. It's a sort of a maturation of your system that you're building. But generally, it helps machines, people understand what you're talking about. It's like storytelling. So this is all to say, and this is a graph I built a long time ago, but this is the idea is once you go through all of those stages, by the time you finish your ontology, you have a knowledge graph. So, this is not rocket science in terms of like we tend to get distracted by really, really pretty shiny things. Graph is graphical in this context, but this is just the graphical view. If you have your ontology, you have a knowledge graph. This is just your pretty picture. So that's something that is important to understand. So part of library science's way of dealing with this is that it's really, really rooted in data preparation. And the same is true for AI systems. Just so you guys know that libraries have been working with AI and automation since 1963 in digital systems with huge networked cross-country projects of catalogs. So there's a lot to learn. And most, again, of the training data, actually, the reason why it's so good is because libraries, anything that's created within the library domain, not everything, but most everything, is going to be focused on this sort of preparation, this iterative process of reconciling and modeling and preparing and cleaning. And that is something we cannot avoid in the library world because there's accuracy, truthfulness, presenting things in as unbiased a way as possible is sort of paramount. And the structure of things, in order to create these huge network systems, we have to structure things and represent them properly. So that is why it's important. So I'm going to introduce you now, and then we're going to go into it in a little bit, but it's a tool called OpenRefine. I don't know if many of you have ever heard of it. It originally was Google Refine until 2012, and then Google set it free into the ether. It's open source, it's free. OpenRefine is an amazingly robust, powerful tool. It was used and leveraged throughout the world by citizen scientists during COVID to create like the New York Times dashboard for COVID cases. There's lots of contributions. It's a wonderful community of people. There's extensions, there's recipes. It's super dynamic and it's really fun to use and it's free. So one thing you can do is you can ingest data in a number of different formats. I think there's up to 8 or 9 different formats from JSON to, just an Excel file to, I think it even reads Python now, but I'm not sure. But anyway, you can pull it in and you can cluster your data. So most of us, especially if you work with machine learning, oh yeah, no problem. But there are within the tool 8 different clustering algorithms available. So you can kind of bump through all of them in one fell swoop and see what works best. And you can also dial in the length and the variances and all that stuff. So this is from a data set that I had was working with and built. You can see Mario Party. It's finding the key collisions there. But It does a really good job. So the first step is cleaning your data. And I do this mostly from just simple clustering. It's really, really helpful. So I'm going to skip over some, but essentially you can go through all of the different variations. You'll find duplicates, you'll find differences in casing, but you have to get rid of some of those because it can be really confusing, heavy, and sort of it becomes noisy, as you know, when you have all these variations. And so these are more examples of some variations. Some of them are unique and some of them are not. You can see there's like spelling differences and punctuation. And you can also cluster in order to shape a taxonomy. So as you can see here, it will, I have a sort of interesting way to do it where if you see what's highlighted in pink, it says export clusters. I'll shape my data like this when I find that it groups things nicely in a massive data set and I'll export it. It exports as JSON. I turn around, I import it back into my open refine, and I'll end up with a spreadsheet view, removing white spaces and what have you. It's just very helpful to have a starter to be able to start to structure your data and refine it further. So you'll also see that you have all these export options. You can template it, you can export it as JSON. There's a number of other, you can even connect it with the API, you can connect it into Google Drive. So there again are a lot of options for exporting. You can even connect it to a SQL database. But this is essentially, this clustering process is aimed at helping you to arrive at your primary data set and your primary shape. So this is important because we end up with terminology that's super ambiguous and you may think is not a big deal. But when we look at something like the word accessory, every domain I've ever worked in, and I've worked in building taxonomies and knowledge graphs and thesauri for more than 25 years. For anyone from Amazon, I now work for Adobe, Overstock.com, the US government. Any domain is going to have accessory. But contextually, accessory can mean a very different thing in different contexts. So this is really critical because being able to say what type of accessory is our aim. Because if you feed this to an LLM, or if you simply do a Google search for accessory, context matters. If you just have the word accessory, if you ask an LLM just to create a taxonomy for you and you just have the word accessory, that context could be defined as anything. Not only that, but accessory can also be an adjective. So you could be an accessory to a murder, and that's not really what you intended to represent. And that can make things go way off the rails. So it's really important, this disambiguation and defining process. Another thing that is helpful is linked data. And the reason why I'm presenting this now is part of defining is finding where these things exist in the open world. Many of you may use Wikidata, but the whole idea is that you're trying to improve interoperability, you're enhancing discovery, and you're giving contextual understanding to a machine. And that is what an LLM needs, is that context. So linked data is a way to further define data. You'll see, basically what happens with linked data, and this is part of the librarian's way, is that we don't only define a concept, but we include an HTTP identifier to a wiki page, to a resource in the open internet from knowledge graphs. And that aims to have an agreed upon meaning of the data and helping to define your data. It is critical that you have some way to reconcile and anchor a concept in space, like the word accessory. What type of accessory? It could be a pet accessory, it could be a computer accessory. Whatever it is, you want to find that concept and link it. So an example, part of this linked data principle you may or may not know about, but Tim Berners-Lee spoke about it pretty to great extent. And it was one of the first founding principles of the internet was linked data, linking pages. It was the principle that was founded by also, or was brought into Google for Google search. Linked data is fundamental and foundational to the internet. And LLMs, because LLMs are trained on the internet, or AI is trained on the internet, it's leveraging linked data in order to reconcile entities. It's part of the reasoning engine. So part of the reason why we structure data in such a way using ontologies is because we're helping to disambiguate, define, and present a logical model that makes sense to machines and people. So, in terms of building a semantic system for AI, a lot of us hear semantics and it can be pretty confusing. It's not just a label, it's not just having a tag. You need to have that full structure. It's layered approach where you have your instances, which would be the linked data, those links that validate it. You have your vocabulary layer, that's like your controlled vocabulary or taxonomy or thesauri. And you have your ontology layer, which is the encoding structure. That makes up a semantic system, not just a label. So we're going to go through this process, and I am not sure who's ever heard of this, and I, of course, will share my slides. And I wanted to do a live demo, but I wasn't sure about sort of the stability of my services. Um, so I did it also for preservation so that all of these resources would be here. So for everyone to use. So the first is Protege. It was founded in the 90s. It's from Stanford University and it's an ontology modeling tool. It's super powerful. It's totally free. You can download it, obviously. Do not use Web Protege for this tutorial that I'm going to go through. You want to actually download the desktop version. It's pretty much the standard base software most ontology modelers use. It's not the only thing, but it's free. The desktop, it does use OWL, which is the web ontology language. However, remember, OWL is a way to represent and format your data. It's not an ontology in and of itself. So I see a lot of, as people are starting to learn about how to build these types of systems, I see a lot of conversation about OWL being an ontology, and that will get you in trouble. It's not an ontology. But it is W3C standard compliant. It's a wonderful tool and tons of plugins and community contributions as well. You'll also need your OpenRefine. So the download is pretty easy. And it's only desktop. That's the only version. But there's updates to GitHub. There's a great community and forum. It's a really fun place to live on the internet. So we're going to jump right in, and this is my hacky trick for creating this system. And this is my first try sort of putting this out into the universe and delivering this portion to the public. Um, so the idea is to reconcile. That is one of the hardest things to achieve at scale and in a quick and easy enough way without having or knowing code, right? Anyone can do this. Anyone can do this. So you're basically dealing with the linked data, which is the record linkage. You're trying to match data with available knowledge graph entities. So you're doing data matching, entity resolution. So you may think that accessory sounds like a good idea, but then once you go through this process, you might find, oh gosh, actually what I meant was pet accessory or whatever it is. And it's also good for helping to detect duplicate records because you may not realize that you've modeled things with synonyms. It's a really common mistake. So it will help you refine your data set even more. So the reconciliation service, these are all hyperlinked. So if I share the deck, then you'll have these resources, but there are APIs available for those that are interested. And of course, it's important to clean and cluster your data first. So obviously you start with data, and this is actually a data set I'm working on now. It's a graph that I'm building for a really cool project that's like community-oriented app. So, I have these data points and they were handed to me, and I'm not sure if they really make sense. So you obviously ingest.
Jessica, can you actually go into the point of this project if you feel comfortable sharing so we can ground it for people?
Oh, this one, sure. So it's this project for someone who is creating in the US a community-based project. If anyone has seen like shock or it has seen like Nextdoor, the app Nextdoor, sort of that neighbor app. It's a little bit more than that. The idea is it's a renewable economy for local communities. It's the coolest app in the world. So it's like the idea of resource redistribution and reuse, and repair, like repair cafes. So it's about these sort of renewable and sustainable local ecosystems, where it's really grounded in community and helping each other out. So it's a pretty awesome project.
And so what will the ontology do for these people with the renewable resources?
Yeah. So it will help with discovery, like because right now the internet's becoming extremely noisy because of all the AI generated content, and it's very hard to search and find things that you actually, are of value or that you can find, especially based on location. So it's going to help to make all of these entities more discoverable and findable by structuring it in a machine readable way, so that when a machine is parsing or indexing the site, it's going to be and or people's posts, it's going to be easier to understand contextually the relationships between these things. So, for example, if you have a built environment and built environment has to do with in-home gardening, that's the type of connection if you see on the left-hand side and the L3 level 3, then I can connect it to built environment. And then I have a relationship that a machine can understand. And so if I am searching from wherever location, I'm looking for people that can help me with in-home gardening, say rooftop farming, then it's going to help me get to that place more succinctly. Right now, seriously, the internet has the amount of AI generated content has exponentially grown to the point where filters and search algorithms are having to be more strict with the types of content that they allow through. So this helps from that standpoint. But then also, if there's any effort to make like AI generated content, or if there's an effort to integrate any sort of AI agents or chatbots, all you need is the ontologically enhanced data set, so a knowledge graph. And then all of a sudden you've set your constraints and your context for the LLM. So it makes it very, very efficient to create sort of workflows and also recommendations and things that before you might need someone, an engineer who knows code. You don't need that anymore. This allows you to automate those types of integrations, which is extremely powerful, and have the guardrails in place. So you reduce hallucinations quite a bit. So once you ingest your data, and I'm not going to go through the details because it's very easy to ingest the data, just you ingest. There's just an upload or start or open project. But the most important thing is all of your data will be in there, rows and columns or single file. Doesn't matter. It can be a single column. You will, step one, drop down. So the drop down caret, the last option, go to reconcile. From reconcile, go to start reconciling. So what you'll find is once you press start reconciling, you go to reconcile with semantic vocabularies and knowledge graphs. Under services, I have connected all of these knowledge graphs that are the same knowledge graphs that serve as the training data for current AI systems. This is what's critical. This is what AI or LLMs consume to come up with the facts that it presents you. So these are defined concepts, they're triple stores, they're ontologically structured. So that's why we're here. You'll go to Discover Services, and after you click that button, you'll end up in this beautiful dashboard type view. And there is a long list of all of these different graphs that you can connect to. These are the same knowledge graphs again that LLMs have trained on. So you choose what service you want, and you'll see that it says HTTPS. Pay attention to that as well. You'll also see there are different capabilities. You're going to want to choose, for example, view entities suggest. I tend to like, this is personal preference, to choose services where I can view entities, but I also want suggestions. I want the machine to give me suggestions because I'm not confident in my data set. I want to make sure it aligns with the outside world because you're aligning it essentially with the training data. Then you'll go, because that opens, sorry, this opens in another tab. So you'll go back into your Open Refine tab because it's a web application, by the way. And you'll go to Add Standard Service. Once you add standard service, you'll see that it starts with the HTTP, which is the W3C standard. Semantic Web Standard is HTTP for URI identifiers. You'll drop in your link that you've copied. You'll paste it, so you copied it directly from the dashboard. You have to remove the S. It's really silly that they haven't fixed this, but you have to remove the S or this will not work. Then voila, your graph is connected. You've connected to a knowledge graph and your data is already in OpenRefine. So there are a bunch of options. This is the Getty's knowledge graph. It's actually, as you can see, three, they call it vocabularies, but three separate ones that are networked, which is super powerful. So you can choose in the right hand, you can see where there's like you use relevant details. You can use that for inference or to help with the matching framework. You can choose not to select any of these include at all. You can search, there's a bunch of options. I tend to choose reconcile against no particular type. I tend to not use auto match. And I usually set maximum number of candidates to return to at least 10. You're going to press start reconciling. This is another view from a different graph. So as you can see, they're all going to look different. So the views, this is three different graphs pulled into one view. This is one single graph pulled into the view, and you're going to reconcile. So this looks a little crazy, this slide, but once you press reconcile, you get this progress bar, which is really nice. And once it renders, you'll find all of your terms, or most of them, should have matches. This was a pretty massive data set. All of these are going to be hyperlinked in the graph. So what's really cool is I can mouse over it and I can look, and this is structured, as you can see, alternate hand tool in this case is that came from a particular graph. It was tools, but to that point about disambiguation, maybe I meant hand tools. Like what kind of tool? There are many different types of tools. Tool could mean something in the digital space that's very different from like the gardening space, for example. So it's going to tell me the alternative labels. It's going to give me broader terms, related terms. What I'm doing here is getting to know my data. Like you have to get to know your data. You have to get to know how it matches. You have to get to know also how it's structured in the open world. Because an LLM is not going to understand contextually your unique domain model without definitions and without structure. So this is very important. So once you start familiarizing yourself, you're going to find you can click into any of these hyperlinks. I can see water management. I can then go into the specific instance or graph, and I can start to understand, there's more concepts I can discover or include to help to give my water management more context, more understanding. And really, again, this is about really understanding the shape of your data and starting to shape it as a thesaurus or a taxonomy or controlled vocabulary. This is that first step in the ontology pipeline. It's also important to that point is that most all graphs have a hierarchy. It's really, really important. So this is from the Getty. When I clicked on the term for water quality management, which is a little more specific, you'll see that you can click on the icon to render the hierarchy, and you can have a high level of specificity around that. This is important because you're trying to find, this is like a shortcut to create a hierarchy that makes sense, that can represent your data properly. So once you're there, you can click on the semantic view, and you can see semantic view in that image. When you go into the semantic view, you'll find the HTTP identifier to the graph, and you'll see again you have your triple statement: subject, predicate, object. There are 137 concepts that describe, or triples that describe, water quality management. That's a lot. It's very descriptive. Also within, you'll see that there's, and I included this as sort of to help you guys understand the structure, is part of what's modeled in the Getty is associated concepts, physical attributes, styles. Like you have a bunch of ways of representing things. You'll notice the inference is explicit and implicit. I want it all. That's why I set it to inference being explicit and implicit. You can also download any of these files as JSON, JSON-LD, RDF, triples. You could feed that into an LLM and ask a question and see if that gives some constraints or to around the topic or more context, and it's worth doing or trying. So the Getty vocabularies are pretty, we don't think much of it, I guess, on a day-to-day, and most people are not leveraging the Getty's vocabularies for LLMs, but it really is a superpower. They're super robust. It's easy to align with. And so this is a nice little diagram that shows us the relationships between the different graphs, right? So in total, it's 1, 2, 3, 4, 5 graphs that are networked. And that's where the power comes into play in leveraging something like the Getty's graphs in order to do what we're going to do next. So this is where it gets really fun. So we've already explored the data. In this case, I'm like, okay, Getty looks pretty solid. I think I'm going to go with the Getty for this next portion. There's a bunch of different download formats. That makes me happy. I can export a sample and just look and say, okay, does this look too complex, or is this something I can work with? Is this a lot of noise? Is it, just get a feeling for what it looks like. But again, leveraging this instead of having to go through yourself and define everything explicitly, you can align and define according to this structure. So what you'll do next is you navigate to the Sparkle endpoint for the Getty vocabularies. There's an open endpoint. And this Sparkle is the knowledge graph query language. You guys do not need to know Sparkle. This is the great thing about this. Basically, there is an index, and the link is here. You go to the index, and there's a huge index of already structured queries. You don't have to do anything. They're just easy queries that you can drop in here. And I chose the query all data for subjects. All data for subjects. I dropped that query in and just copy and paste and find subject by any label. Here's the query. And then I have all of my my query results here, and I download that as RDF. It's really easy. Now you remember Protege because you guys had Protege. You're going to set your download file to open in Protege. It'll just automatically open. And now all of a sudden you have a graph, an ontology that has 3,878 axioms. There's a count, there's 14 classes. You have an ontology, you have a knowledge graph, you have your constraint, you have your RAG, your retrieval augmented generation, like that. This is giving the context, the meaning, the understanding to machines. As you go through, you can go to the different tabs within Protege. You will see that you have your classes. That is the root or the foundation of your graph. You have your properties and you have your data types. These are all coming from the Getty's representation or graph from that Sparkle query. This is all free. And there's a tab within Protege. There's a bunch of tabs. And there's plugins, but you want to use the Onto Graph plugin if you want a visual. It's not very fancy, but it's going to render your class hierarchy visually. This becomes the root again, or the foundation. These are just the classes. So you can understand that base layer of how to structure your vocabulary with context and meaning and relationships. It's another view. So it uses, what's really nice is it's using schema.org. They have RDF, which is Resource Descriptive Framework. We have SCOS, we have OWL, like it's actually a really solid graph. There's a debugger feature. So if you're still not sure if it checks out or not, you can go through and you can debug, check everything. It's telling me that there's possible faulty, something might be broken. It was totally coherent and consistent. Uses ELK 5 in order to do that. And this is all really, really fast. So then, and you can see all of the tabs at the top. From the tabs, you choose individual matrix. This is where all the goodness is in terms of the entities. You want to go through and actually delete the entities so you can fill in your own. So each of those numeric identifiers are individual people's names. Unless you want the people's names in there, the idea is to take those out to fill in your own details within. So you can see biography, document, document part, delete what you don't want, keep what you want, but this becomes the foundation, the easy way to structure your vocabulary for machines. And that's the most important thing. So who's doing this? I just want to emphasize who is doing and who's representing their data as such using ontologies as knowledge graphs, structured data. Um, all of these folks are players in the space, and all of these folks link data to one another.
I've got a question.
So right now,
I've got a
yeah.
question. What does Amazon get out of an ontology? What does it allow them to do in terms of their e-commerce?
Oh my God, it's huge. So they're able to link. So for example, starting with books, if you ever go to Amazon for Amazon books, you'll see that it's linked to Goodreads and a number of other, and libraries, actually, the library catalog systems. So within its books realm, it's very powerfully linked. Schema.org, which is Google search. Amazon uses ontologies and linked data for schema.org in order to leverage that for online shopping. So you know how results come up very well defined at the top if you're ever searching for anything to buy online. That's one way that Amazon does that. Microsoft has their scholars, the academic graph, their own academic graph, but they use linked data to link to Google Scholar and also to Amazon and Goodreads and all of the publishers. They all link to one another. So mostly it's used obviously for commerce and for discovery, search and discovery. So when I was because I worked at Amazon, at least in the area that I was in, it was seller support services. And so there was all of the documentation, for example, in order for people to find documentation on how to, if anyone wanted to sell online at Amazon, that is all networked using linked data. So that's one of the reasons it's very important. I just showed you Getty, but you can see Getty's there. Um, and so this is mostly also used for helping to define this for machines. Machines can blow through like search engines. You know that most of Google search is substantiated and held up by ontologies. So to not use this and to not leverage linked data and ontologies is to not speak the same language as machines. It's asking them to decode something that is really hard to decode intuitively and otherwise.
So essentially an ontology, and they were using them back in Yahoo for all the search was basically based on ontologies until Google came around and did their thing. I'm sure Jessica knows a lot more about this. But like going forward into the future in 5 years, you know, maybe our world is different, it doesn't have semantic search as much, but the semantic search is actually improved through the LLMs because you can do an embedding model and basically give the semantic search a better opportunity to use natural language. And we also have chatbots. Like, how does everything you have up on the screen change over the next few years? Does it just get more and more entrenched? And like, where does the ontology fit in with the LLMs?
Yeah, I mean, this is like because all of this is foundational to the actual training data. So LLMs wouldn't exist if it weren't for training data. And most of us think, oh, well, training data is just feeding a bunch of documents or stuff to LLMs. And we know it's the internet, but we just figure it crawls or it scrapes. That's not how it happens. It prioritizes and prefers linked data and ontologies, which is why these players on this screen are so powerful and yes, becomes more entrenched. Lucky them, they got to define LLM's primary understanding of the world. That's what's so powerful. These folks on the screen had the opportunity to define what we now know as like ChatGPT. That's what's so powerful about it. And
It's
so the,
basically
yeah, go ahead.
it's basically they built the infrastructure not only for the internet we have now, not only for the LLMs, but they were back in the 1980s, 1990 building the infrastructure that eventually became the internet and now
Yeah.
is becoming the LLMs themselves.
Yes. Yeah. It's super, it's like amazingly powerful. So it's sort of like, why wouldn't you want to speak the same language? And why wouldn't you want to leverage this goodness? It's not all perfect, but without context and without meaning, that's why LLMs hallucinate, is LLMs are trying to figure out what you're talking about, what you're asking, what you want. And with costs, we don't also know what the cost is going to be for AI systems going forward. Right now, it's been, pretty open. Um, but if anyone works with it at an enterprise level, it can get very expensive very fast. And so this is another way to economize rather than letting the engine run and just taking stabs in the dark. You're introducing a high level of specificity by defining your data and the relationships between things. Because again, you're giving how there's context windows with AI. Those context windows, you don't have to use them as much if you structure your data properly. So there's she was a Wall Street Journal or columnist, and the other reason why this is super super important, she wrote in 2022, and I just love this piece it that she wrote it that AI systems are cultural technologies, and one of the reasons why that is also because like paper was a cultural technology, the printing press was a cultural technology, the internet's a cultural technology. And so the screen, these are all part of the cultural technology ecosystem. We look at these and we're like, oh, NIH or NHS, or these are sort of brain trust institutions, a lot of them. But in fact, like the internet works in large part because of these folks. That's why. And then when we look at AI systems, it's the next iteration, it's the next step, it's another cultural technology. And in so being, that's why those foundational systems are so important to connect with because it helps to define these technologies culturally, but also helps to ground how you represent yourself or your data or your context or your meaning and anchor it in that truth or in the culture, in whatever that cultural system is. It's really, really important. And without using, the thing is that we expect AI to just magically be intelligent, but in fact, it's a statistical model. And so it becomes intelligent when you introduce your own intelligence to it and your own intelligence system to it. Then it becomes really powerful. And so as a cultural system or cultural technology, much like the internet, how you present and how you structure and how you define your space is super important. I'm going to skip over that slide, but this is like really the evolution or the coming to or coming into itself of the semantic web. For years we were talking about the semantic web, but the semantic web, which came from Tim Berners-Lee, one of the founders of the internet, um, he evangelized linked data and structured data and RDF, ontologies. That was his original vision. And it never really happened. And everyone spent years laughing at the idea of it. But it's interesting because we come full circle now. And largely what's been proven to be effective uh, and to help AI systems be more proficient as partners um, is a semantic system. And the semantic system is built on those founding principles of the semantic web, those same founding principles. So it does feel like, and this is my personal sort of editorial on it, is we used to whisper about this, but now that it's sort of come full circle, it we're learning that the semantic shape is really important and semantic meaning is really important. Semantic systems are important and the linking of things is really important, that we need well-defined meaning so that we can work in cooperation with machines, not against machines. So that's it. That's my dog chunk. And I used Firefly for this one, which is an Adobe product. But yeah, and I do have a website now. It's called ontologypipeline.com. And so I'm going to be, putting together a more formal course. So you guys got to be my test bed for some of these concepts. So I'd love feedback, by the way.
Yeah, that was really great. So we only got a few more minutes left and I'll ask one more question. What do you see people doing with AI that they shouldn't do when it comes to knowledge management? And actually, let me set that up before. Knowledge management is basically, you have all work is now knowledge work. All companies are now involved with knowledge work. So knowledge management, and you have a company of like 10,000 people. How do you manage all of the knowledge resources? Because that's what all these companies are doing. So like what inside of AI, or how are people using AI wrongly in knowledge management? How should they be using AI in knowledge management?
Good question. Using AI only to just blindly define and create your structure. So a lot of people will say, hey, give a prompt that is just clean up my data or define my data or create a taxonomy for my data, and it can do okay. But that's a place where I don't think that you want an LLM to be the starting place for it, or AI to be the starting place, because it's probably the most important step or phase is first defining and contextualizing it yourself with assistance. Um, because right now, at least, I think this may change in the future, but right now, when you ask an LLM or AI system to create some structure for you, it again can hallucinate, but it also gives, it's using open data. And so you're going to get someone else's structure. It may just lift and shift the entire Getty structure. And that then becomes your structure. And it's really important that your foundation for your knowledge management is solid and accurate, because then you want to build upon what you've defined. So you don't want a machine necessarily to define it for you, because it's basically defining the context of your entire knowledge management space. And I would think that you'd want to have some say in how that is modeled and rendered, which is why I presented this process, because it's a way to do it in a more in an easier way, but checking it against sources that exist. And then there's the human in the loop where you can then make decisions accordingly. So
Important. Well, thank you so much, Jessica. A round of applause for Jessica.
thank you, guys. I hope you definitely reach out to me. I'd love to hear from anyone and I'll share out my deck. I'm happy to.
I'll put it in the WhatsApp group later. Thanks, Jessica.
Thank you, Stuart.